my pre-algebra friends, we're going to dive a little deeper into the topic of integers. So we're going to go over integers, absolute value, and then comparing and ordering integers. But first, let's start with the main word, integers. An integer is a whole number or its mathematical opposite and 0. So that mathematical opposite means that they are on mirror images of that number line. So let's say 5, which is a whole number, is an integer. Its mathematical opposite, -5, would then also be an integer, and then, of course, 0. And this goes on infinitely to the right and then to the left on the number line. To the right, we're getting bigger. To the left, we're getting smaller. So like 10 is an integer, 20, 27, 32, 1,314,912, right? All of those are integers, whole numbers. And then their mathematical opposites, -10, -1,314,912. So positive whole numbers, their mathematical opposites, and 0. So let's talk about what's not an integer. Integers are not anything between those kind of main tick marks on a number line. So like decimals are not integers, right? Anything that has a whole number and then a little bit more, not an integer. So like 3 and 5/10, not an integer. 6/100, not an integer. Decimals are not integers, and fractions are not integers. Because again, fractions by definition is part of a whole, and which makes it not a whole number, makes it part of one. So like 1/2, 5/10, not an integer. 3/4, not an integer. -2/3, not an integer. And also we can include with fractions is those kind of mixed numbers. So 1 and 1/5, not an integer. Anything that is part of something else, not an integer. And then the last one, non-examples, would be percents. Percents are not integers. So because by definition, percent is part of a whole thing. So 75%, not an integer. -150%, not an integer. So integers are not fractions, decimals, and percents. But just like in life, there's rule breakers out there. There's things that just kind of go against the grain and they're just different and they break those rules. So I just got finished telling you that fractions, decimals, and percents were not integers. But what if I have a decimal that looks like this? Well, 4 and 0/10 is just 4. So even though, yes, it has that decimal, that 0 is just a placeholder. So this would technically be a rule breaker. It's a decimal, but really it's just 4, which makes it an integer. If I have -5.000, right? Like I could add zeros infinitely as long as I'm only adding zeros, not, that's just a rule breaker, right? Not an integer, which makes it an integer. So those are our decimal rule breakers. Our fraction rule breakers are like not mixed numbers, but improper fractions that equal a whole number. So like 5/1, 5 divided by 1 is 5. So that would be a rule breaker, right? It's a fraction, but it's also an integer. Like 10/2, I just have 5 stuck in my mind, right? Is 5. So that makes it an integer. So it would be a rule breaker. And so then when it comes to percents, well, we're looking for whole things. So if I have 100% of the pizza, I have one whole pizza, which makes it an integer. If I have 200% of pizza, I have 2 whole pizzas, which makes it an integer. So these are our rule breakers. So just be careful for those 100% kind of intervals, those improper fractions that equal a whole number, and those decimals that just have those 0.0s or 0.000s. Anything like that, rule breakers. So let's look at a number line and then define the term absolute value. The absolute value of a number is the number's distance from 0, right? So distance from, if you're taking notes, 0. 0 tends to be in the middle of like a standard number line. Obviously, it separates the positives and the negatives. And then we have positives on the right. This is simple. And negatives mirror those mathematical opposites on the left. The further right you go, the bigger you are. And the further left you go, the smaller you are. So like left is least when it comes to ordering and comparing. So if we're talking about this term, absolute value, right? A number's distance from 0. You see absolute value kind of in these jail marks, right? So if you see a number kind of locked there in jail, those two things right there, that's the absolute value symbol. So the absolute value of 3 would be 1, 2, 3, because 3 is 3 hops from 0, right? So we're talking about distance. Well, if I look at 3's mathematical opposite, -3, well, -3 is here to the left of the 0 on the number line. And to get to it, I go 1, 2, 3. It doesn't matter that I hopped 3 steps to the left. Any movement is movement, right? So distance is always positive. So it doesn't matter if you go right 3 or left 3. Absolute value, the answer to an absolute value question will always be positive because distance is positive. So mathematical opposites have the same absolute value. Pretty interesting, right? I know. So now we're almost to the end. We're going to order some integers. So when we're talking about ordering integers, there's a couple vocabulary words that we need to know, like ascend and descend, right? So when we ascend, think of a mountain. All right, my dad really likes to hike. So think of a mountain. That's maybe like more of a hill, but whatever, we'll go with it. So when I start down here I am, and I go up the mountain, I'm ascending. Oops. Boop. Right? So when I go up, I'm ascending. So I started at my lowest point and went to the peak, the greatest point. And once I'm up at the peak, I have to come back down the mountain, which means I'm descending. Right? So that means down, right? Down, which means I started at my greatest point and I went to the least. So say I have a set of numbers. We'll just do like -10, 7, -6, 8, and 14. If I wanted to put them in ascending order, right? Remember, ascend, I'm going up that mountain. So I'm going to go least to greatest. So when I put things in ascending order, I'm going to look at the negatives first. I have -10 and -6. Well, I know that the farther left I go, the smaller I am. So on the left-hand side, it's kind of like opposite world, right? The bigger the number, the base number, the smaller it actually is. So -10 would be less than -6, right? So then I mark those two off. Now I just look at my positives. I have 7, 8, and 14. Well, that's easy. I know that 7 is less than 8, which is less than 14. So that's really simple, kind of quick way to put integers in order. Main part is vocabulary. Ascend, least to greatest. You're going up that mountain. Descend, greatest to least. So I would start, if I wanted to put them in descending order, then I would start with the 14 and then greater than 8, greater than 7, greater than -6, greater than -10. So ascending order, descending order. We're going to skip that example and just briefly talk about comparing integers. When I compare two integers, I'm just looking at the main symbols, right? So think about those alligator, right? The alligator always eats the bigger number. So if the alligator is facing the first number, that means greater than. And if you don't like the alligator analogy, we can do a Pac-Man. The Pac-Man faces away from the first number. That means less than. And of course, if they're equal, that's just equal to, right? That means that they have the same value. So let's say they take these two negative numbers. Let's do negative 11 and negative 20. Negative 11 is what to negative 20? Well, if I think on the left-hand side, remember, left-hand side is kind of backwards world. The bigger the base number, the smaller it actually is. So the negative 11 is farther right, which means it is greater than negative 20. If I look at like 8 and 10, 8 is less than 10. So remember, the alligator is always going to face that bigger number. But I know you know that because you're pre-algebra. I just have to go over it with you really quickly. So that is our lesson today about integers, absolute value, and comparing and ordering. You're now going to move on to the practice portion of today and work on your activities on your Google Slides. If you have any questions, let me know. Love ya. Bye.